ESR stands for equivalent series resistance in case of a capacitor or inductor. It can be considered as the internal resistance of a capacitor. Low ESR capacitor allows for more efficient current flow with less dissipation of energy as heat. They are ideal for applications requiring fast charge-discharge cycles like high-frequency circuits. They can improve signal quality and increase stability. In non-electrolytic capacitors, the resistance is a combination of that offered by the leads and several mechanisms in the dielectric material. In case of electrolytic capacitors, resistance offered by the electrolyte also come into action. Ceramic capacitors have ESR in the range of 0.01 to 0.1 ohms. Aluminum and tantalum electrolytic capacitors with non-solid electrolyte have much higher ESR values of several ohms. ESR decreases with frequency up to the capacitor's self-resonant frequency. ESR increases over time from evaporation, especially for aluminum electrolytic capacitors. This can cause circuit malfunction and even damage, though the measured capacitance may be within the tolerance range. In addition to aging of the capacitors, high temperatures and large ripple current can worsen the problem. When the ripple current is significant, increase in ESR can increase heat accumulation and accelerate aging, setting up a vicious cycle. Electrolytic capacitors rated for high temperature operation and of higher quality are less likely to become prematurely useless due to increase in ESR. Picture shows a 47 microfarad tantalum capacitor in my Arduino Nano microcontroller board as a representative image of a tantalum capacitor, though I am not aware of the ESR of this capacitor. Most likely it is a low ESR variety. Polymer capacitors have low ESR values than wet electrolyte capacitors of same value and are stable under varying temperatures. They can also handle higher ripple current. Hence, they are being used in computer motherboards instead of electrolytic capacitors. Polymer capacitors use solid conductive polymer electrolyte. There are polymer tantalum electrolytic capacitors, polymer aluminum electrolytic capacitors, and hybrid varieties. ESR can be measured using an ESR meter without the need to disconnect the capacitor from the circuit it is connected to. Usual capacitance meters cannot measure the ESR. Some LCR meters can measure the ESR as well. Standard multimeters cannot be used to measure ESR because a steady direct current used by the multimeter cannot be passed through a capacitor. Direct current flow is high initially and stops when the capacitor is fully charged. ESR is measured by applying an alternating voltage at frequencies at which the capacitor's reactance is negligible.